All right, so a quick video explaining how to calculate the correlation coefficient exactly. All right, so far we have just been estimating the correlation coefficient. All right, so we might get a scatter plot like this one here, and we would say those dots are going up from left to right, so the coefficient will be positive, it will be plus. They're they're kind of decently formed around a straight line. So maybe plus 0.8 for that one. For this one here, they're definitely going down from left to right, so negative, minus, quite close to forming a straight line. So I would say maybe minus 0.9-ish for that one. This one here, again, they're going upwards. Okay, so I would say plus, not that formed around a straight line though. There is a bit of movement if you were to draw a line of best fit on it. So 0.5 maybe, plus 0.5. This one here, negative again, it's going down, it'll be minus. There's a gap, but we're not too worried about that. It's about how close they are to forming a line. Okay, so I would again say minus 0.9, quite close to minus 1 for that one. Okay, now all my guesses, my estimates there could be off a little bit. You get better estimating them as you do it more often, but there is a way of calculating that correlation coefficient exactly, and that's what we're going to do today. Okay, there is a formula to do it, and you can do it by hand. That's it there on that slide. It looks fairly tough going. It's not as bad as it looks, but there is still a fair bit of kind of calculation and kind of work behind it. So I'm just going to get you to do it using an online calculator. Okay, just briefly a couple of words on the correlation coefficient. It's not the slope of the line of best fit, so it doesn't really matter how steep or gentle the slope of the line of best fit is. That doesn't affect the coefficient. Okay, it's how close they are to forming a straight line that affects the coefficient, that makes it go closer to 1 if it's going up, or minus 1 if it's going down. Okay, so always between minus 1 and 1. The number is the strength of it. The sign then is the direction. Okay, so minus 0.75 and plus 0.75 have the same strength of correlation. They're just going in different directions. It is affected by outliers and can be quite badly affected by outliers. If we look at this example here, I've got a scatter plot with a correlation coefficient of 0.89. If I take the same points and just add 1 down here, so it's quite far away from all the other points, it is what we call an outlier, it brings the coefficient all the way down to 0.21. So we've gone from 0.89 to 0.21. So if I was kind of doing a question like this, or if I got this in my assignment, I would probably calculate the coefficient with and without that outlier, and I would say the correlation is quite strong without it, and the outlier brings it right down. Coefficient's not affected by changes in units. It's, let's say one of your variables is distance. It wouldn't really matter if you put that distance in miles or kilometers or meters or yards or feet or furlongs or anything you want. The coefficient will stay the same. Okay, so as I said, I'm going to show you how to do it on an online calculator. I will link to it in the Schoology comment, Schoology post that I put this up with. On the ordinary level course, you only need to be able to estimate the coefficient from a scatter plot. So what we've done already, what I did very briefly at the start of this video. On the higher level course, you need to be able to calculate it exactly. You need to be able to do that with a Sharp or a Casio calculator. I have instructions up on how to do that. So if you want to teach, if you know you're going to be doing higher level and you want to teach yourself how to do that now, there is instructions up there on Schoology as to how to do that. But because calculating exactly is not on the ordinary level course, I'm just going to do it using this online calculator. Okay, so as I said, I will link to it, but if you just Google correlation coefficient calculator, it's I think the first and second result both go straight to this. All right, so page should look like that. First example I'm going to do is one you've seen already. Okay, so I think this was the very first scatter plot that you did or you finished off in the first class. So I'll just leave that scatter plot there for a second and you can estimate the coefficient. So I would say the points are quite close to that line of best fit. You've got two outliers here, so they're going to bring it down. I would probably guess around about 0.7 for that, just because almost everything is quite close to the line. It's just this one's a little bit far away and this one's quite far away, but yeah, about 0.7 would be my guess for that one. So if I get those up together. All right, so you see you've got a box here for X values, a box for Y values. It doesn't matter which is which. So I could put years of education in as the X, or I could put it in as the Y. I would still get the same answer. Okay, I'll put years of education in as the X. So 11, 12, 13, 13, 14, 15, 16, 16, 17, 17, 17, 19. Y values then 28, 30, 35, 43, 55, 38, 45, 38, 55, 60, 30, 58. Okay, while you can put whichever one you want in X or Y, they do need to be in the correct order. Okay, so the 11 goes with the 28, the 12 goes with the 30, the 19 goes with the 58. So they need to be entered in the correct order in your boxes. All right. You see this income here is in thousands of euro. I could have written 28,000, 30,000, 35,000 if I want, but it's going to give me the same answer. That's kind of like that miles, kilometers thing I was mentioning a second ago. Once you've got them all entered in, just make sure you got the same number of entries in both boxes. That's a quick way of checking you haven't left anything out. But calculate OR, and there it is. Okay, the value of OR, so OR is the correlation coefficient, is 0.6232. So close enough to my guess of 0.7. All right, I'm just going to do one more example. If you scroll down this page, you're going to get a whole load of, this is basically all the numbers which are behind the calculation of it. So if you did want to do it by hand, you'd be doing a lot of this stuff. And if we go down to the end and just reset here. Okay, so if you click reset, it's going to take you back to those two boxes again. And I'll just put, yeah. Okay, so this is another one that we did I think I did this one on the board. It was about the age of runners and the time it takes them to win run a race. So there's the scatter plot there. So it's negative, so it's going to be minus. I would guess around about minus 0.9 maybe for this one. Okay, so let's enter our values in. Let's make age the X. So 33, 33, 31, 26, 26, 25, 30, 29. Okay, now age was the X when I put it on the scatter plot, but as I said, if I put all of those in the Y, it wouldn't matter. It would still give me the same answer. Y values then, so 132.6, 132.1, 133.1, 134, 134.1, 134.6, 133, 133.5. Okay, same number of numbers in both boxes. That's a good quick check to do. Calculate OR minus 0.9724. So I said minus 0.9, so that's kind of, yeah, in the range I'd be expecting. It's very, very close to forming a straight line. All right, so what I'm going to get you to do is this worksheet here, which you did, I think, in the second class we had. So you've drawn scatter plots for each of these. So if you have your copies there, dig those out, have a look at the scatter plots and estimate the correlation coefficient from them. and then do the actual calculation. Okay, so for each of these, I want you to enter the numbers into the calculator that I just showed you, and I will put the answers up as well so you can check them.